Let's continue with our tutorial, all right? So this is part 2 of the nonlinear static analysis on a rivet and a plate with a hole. So let's create the other one. So the second one is interaction to surface contact. We hit continue. So now, as we can see in the geometry, I didn't put it in one surfaces, but we can see we have two. We have this, we also have this one. So I know this one is in contact with this, and the other one is in contact with the other here. So I will create two more interactions. So first I click this and I hit done, and then I hit surface here and go to the one here and hit done. And now I will create another one because this is not just hard contact, but it will be tangential contact, right? So I will hit here and go tangential here. Where is the tangential? Let's just create contact 2, right? So contact here, continue, mechanical tangential behavior. You have frictionless, penalty, and the other one that you can even put some coefficient. But yeah, I will keep the frictionless. So I will keep with the frictionless, right? So frictionless, and this is okay. Let's go okay here, and let's change and go contact 2 and hit okay. So now let's create the other interaction, which is surface to surface contact. You go here, you hit done, you go surface, the other ones here, done, and you change here, take the contact 2 because it's more of the same, and you go okay. So now we're fine. So we can go on boundary condition or loads and boundary condition, right? So I'm not gonna apply a load, but a displacement. Yeah, and I measure this. I know it's about 7-8 millimeter. I mean, from this edge to the plate, it's about 78 millimeter. Okay, you can also measure it here on tools. You go query and you search for the measure tools or the distance tool, and you can measure the distance, but I know it's 78 millimeter. So what I'm going to do is to apply a displacement that is more or bigger than the 78 millimeters. So in that way, I know this face should go harder on the plate so we can see if the material will fail, right? So yeah, so let's go here and apply a displacement here. Displacement 1, and let's go here, displacement, yeah, displacement or rotation. You go continue here, and I will select the top surface. You hit done. So now I know it's along the z-axis, right? So here it's going to be 0, and u2, I don't want it to move to the u1 and u2, but to the u3 it's going to be a minus. I said the distance was 78 or 79, so I will put just 80 in order to impose a bigger distance than the actual one. So in that way, the this will not just stop in the surface, but will go down, and we will see. So 80, so in the rotation, 0, 0, 0. So you can also come here and create some amplitudes and stuff, go tabular, but I'm not going to do that, right? I will just apply one time and ramp, right? Okay. So what I will do right now is the boundary conditions on the plate. So let's say fixed support, okay? It's going to be a fixed support. I can take the first one because it's more quickly, and I hit here. I take all the edge, and yeah, I can also take just two ones. I think two ones will just be enough. Not this, but the surface. And I hit done, and I will just take the anchor straight and okay. So this is enough, right? With the boundary conditions, we're fine. So what I will do right now, you can also see here the arrows that projects that this will move downward, right? This rivet will move downward. So now let's go on mesh, right? So part, and I will click here, and it's 20, and I hit OK. So 20 is now gonna work. I put 18 because I want to have the larger mesh possible, because this is not what I want to analyze, right? I want to analyze by the plate, the behavior of the plate. So the rivet, I don't really care about how it's going to deform, because I know it's not going to fail, or even if it's going to fail, but it's okay. It's not what I want to see. I want to really visualize the plate, the rivet, even if the material fails. No, no. So mesh cut 3 times or 4. So now the mesh, right? So let's go on part here, because I would do one by one. When I was creating the assembly, I made them independent. So I click here and I will put 18. I want to have a larger mesh because I don't want to have a result that are going to, I mean, a simulation will last if I put smaller size, right? So, okay, down here, I hit generate the mesh. Cannot be meshed automatically using the assigned element. So what I would do, because that's true, the automatic one is not going to work. I need to go and change the type of mesh, right? So I go here, SAR, and no here. I will hit this, the mesh control, and I will put that here. Okay, so now we're fine. I can generate the mesh right now. Yes, so now that's fine. So I know this mesh is larger, but I do it on purpose. I don't want my result to last forever, right? So let's go on plates, because only for you to understand. So I don't really need to go on final mesh, but you can go on the link below and hit there. You will have those access of those tiny details that I'm going to share with you, right? So if you go on the link, you subscribe, and I will give you the access with those details, right? So I will hit here. This is the most important one, especially here around the plate. I want to have finer mesh around the hole, but all along here. I mean, here on the plate, I don't care about this area, so I will have a larger mesh. But around the hole, that's where I want to visualize my results. So I'm going to refine in this area. So how to do that? You will click this. You hit the edge. No, not this one, not this one, but this. Yeah, you select the shift. You click this. You will go here. The other side, you hold the shift button, you click this, you hit done, and you will give even 2.5. It's okay, right? But the global size, I will give, let's say 20, a larger mesh. I do it on purpose, right? So done. So you will see the mesh. That's what I have. So you can see it's a finer mesh around the hole, but larger mesh here when you're going far away to the hole, but it's okay for me. So let's create a job, right? So you can click here, job one, or let's give a name, simulation one. And now we hit continue here, and you will go here with the okay, and you go back to the manager, you will submit your work. All right, so now let's wait for results. So we have results. Let's go and visualize them. You can also come here on the monitor. In case you have some warning, you will read them, and you go on errors and you see, but we don't have any errors. That's why we have a completed result. So let's go results and let's hit this. So you can see that our the highest stresses value are 959. So we are above the limit, the elastic the limit elastic of the steel material. That means our materials went plastic, right? So yeah, let's analyze first. So let's go on animation here. You can see this is how it's moving, right? This is how it's moving, and you will stop here. You will click here and go at the beginning. You will go here at last. But let's hit this and let's go smaller, and you will see this is how it's go. Yeah. So as you can see here, that we exceeded the limit elastic here. That means our material went plastic. Let's just say we want to analyze the plastic deformation here. What you have to do is to go here on property and you hit this, or let's just go and edit the one that we have here, and we will change the name here, and we will not have a steel, or even if you have a steel, that's okay, but you will put here a plasticity plastic, and you put the values, and then you can analyze the plastic deformation. But because of we don't have that, we don't have the plastic deformation values, the plastic properties, so that's why we cannot analyze the plastic deformation, right? So if you guys are interested with with those kind of things, you can comment below, and we will try to. If you guys are interested in those plastic properties stuff, you can comment below, and I will make a video about that. And yeah, so here we have this value, right? So this value, you have a lot of things you can see. You have the stresses, you have the displacement, which is very important. You can see that we have 80 millimeter of displacement. That's really, really big, right? So another thing you can do is to create graphs. So if you guys are interested, you can comment below if you want to know how to create graphs, right? So that's here. That's where you create graphs, right? You can create graph, the stress strain graph, the other graphs that you want, any kind of plotting, you can go there and create them. And that's really, really great. So I hope that helps.